Hello everyone, today we are here to discuss about Biopharmaceutics and Pharmacokinetic previous year question which is presented by Rushali Patil, Prarthana Mane, Pratibha Veta, Sania Tambole, Siddhartha Vaidande. Student of Ashokram Mane Institute of Pharmaceutical Sciences and Research Survey. We are thankful for guidance of Mr. A. N. Dage. We are discuss about definition of bioavailability and bioequivalence, also pharmacokinetic and pharmacodynamic method of assessing bioavailability. First definition is bioavailability. Bioavailability is defined as the rate and extent of absorption of unchanged drug from its dosage form. Rate, acute condition, asthma, pain, etc. Extent amount, chronic conditions, hypertension. Then equivalence. Equivalence is a comparative term used to indicate that two or more substances labeled as equivalents are similar to one another with respect to a specific characteristic or function. The second definition is bioequivalence. It is a relative term that denotes drug substance in two or more identical dosage form reaches the systemic circulation at the same relative rate to the same relative extent. Plasma concentration time profile will be identical without significant statistical differences. Then method of measurement of bioavailability, which is involved two methods. First is pharmacokinetic method and second is pharmacodynamic method. First, pharmacokinetic method. These are very widely used and based on the assumption that the pharmacokinetic profile reflects the therapeutic effectiveness of the drug. These are indirect method, which involves two methods. First, a plasma level time study and second, urinary excretion study. Then second method is pharmacodynamic method. These methods are complementary to pharmacokinetic approaches and involve direct measurement of drug effect on pathophysiological process as a function of time, which involves two methods. First is acute pharmacological response and second therapeutic response. Plasma level time study. It is the most reliable method and method of choice in comparison to urine data. The method is based on the assumption that two dosage forms that exhibit superimposable plasma level time profiles in a group of subjects should result in identical therapeutic activity. Plasma level time study shows three important parameters. First is Cmax, second is Tmax, third is AUC. First parameter is Cmax, the peak plasma concentration that gives an indication whether the drug is sufficiently absorbed systemically to provide a therapeutic response. It is a function of both the rate and extent of absorption. Cmax will increase with an increase in dose as well as with an increase in the absorption rate. Then second parameter is Tmax, the peak time that gives an indication of the rate of absorption. It decreases as the rate of absorption increases. Then third parameter is AUC. AUC means area under the plasma level time curve. That gives a measure of the extent of absorption or the amount of drug that reaches the systemic circulation. Graph shows time versus concentration as well as important parameters like Cmax, Tmax, AUC, duration of action, onset time and therapeutic ranges like MTC and MEC. Then second method, urinary excretion study. This method of assessing bioavailability is based on the principle that the urinary excretion of an unchanged drug is directly proportional to the plasma concentration of a drug. As a rule of thumb, determination of bioavailability using urinary excretion data should be conducted only if at least 20% of administered dose is excreted unchanged in the urine. These show three important parameters. First, dxu by dt max, second tu max, then third xu. First parameter is dxu by dt max, the maximum urinary excretion rate. It is obtained from the peak of plot between rate of excretion versus midpoint time of urine collection. Then second parameter is tu max, the time for maximum excretion rate. It is analogous to the Tmax of plasma level data. Its value decreases as the absorption rate increases. Then XU, the cumulative amount of study excreted in the urine. It is related to the AUC of plasma level data and increases as the extent of absorption increases. This method involves collection of urine at regular intervals for a time span equal to 7 biological half-lives, analysis of unchanged drug in the collected sample, determination of the amount of drug excreted in each interval and cumulative amount excreted. For obtaining valid result, following criteria must be met further. At each sample collection, total emptying of the bladder is necessary to avoid errors resulting from addition of residual amount to the next urine sample. Frequent sampling of urine is also essential in the beginning in order to compute correctly the rate of absorption. This graph shows midpoint time of urine collection period versus rate of urinary excretion. Then acute pharmacological response method. When bioavailability measurement by pharmacokinetic method is difficult, inaccurate or non-reproducible, an acute pharmacological effect such as a change in ECG or EEG reading, pupil diameter, etc. is related to the time course of a given drug. Bioavailability can then be determined by construction of pharmacological effect time curve as well as dose response graph. The method requires measurement of responses for at least 3 biological half-lives of the drug in order to obtain a good estimate of AUC. Then disadvantages of this method. First, the pharmacological response tends to the more variable and accurate correlation between measured response and drug available from the formulation is difficult. That second, the absorbed response may be due to an active metabolite whose concentration is not proportional to the concentration of parent drug responsible for the pharmacological effect. Then therapeutic response method. Theoretically, the most defined, this method is based on observing the clinical response to a drug's formulation given to patients suffering from disease for which it is intended to be used. Then this method shows some drawbacks. First, quantitation of observed response is too improper to allow for reasonable assessment of relative bioavailability between two dosage forms of the same drug. Then second drawback, bioequivalence studies are usually conducted using a crossover design in which each subject receives each of the test dosage form and it is assumed that the physiological status of the subject does not change significantly over the duration of study. Thank you.